Nothing really new in this video. I just want to give you more practice, more things to look at, more examples, more wait times of me going through the process. So example 4, a factory is manufacturing chairs and tables. Each requires 3 operations. Whew. Cutting, assembly, and finish. First operation can be used at most 40 hours. Okay, so cutting, we have 40 available for cutting. The second is 42, so 42 for assembly. And the third, which is finishing, is 25. This is how much is available. All right, a chair requires 1 hour cutting, 2 hours assembly, and 1 hour of finishing. A table is going to be double the amount of cutting, 1 hour of assembly, and 1 hour of finishing. If the profit is $20 per chair and $30 for a table, how many should be manufactured of each to maximize profit? Okay, so step 1, what are our variables? Look at what it's asking. Those are our variables. How many of each? Okay, so let's let C, I've been using a lot of X and Y, C be the number of chairs to produce. And let T be the number of tables. That was step 1. Step 2 is the objective function. We want to maximize the profit. What's our profit? Our profit is, well, we profit $20 for every chair and $30 for every table. Step 3, constraints. All right, so we need the constraints. Well, that's going to be the hours of cutting and assembly and finishing. So we'll have 1 for cutting, 1 for assembly, and 1 for finishing. And we'll also assume that, right, chairs and tables have to be non-negative. So we have 40 available for cutting. A chair takes 1. Chair takes 1 hour. We have 1C. And a table takes 2 hours, so 2T. We can't use up more than our 40 available hours for cutting. Assembly, a chair takes 2, and a table takes 1. We can't use more than our 42 hours available for assembly. And we have 1 for finishing too. A chair and a table each only use 1 for finishing. So we can't use more than our available 25 hours? Kind of hard to read. 25 hours for finishing. So now we have 5 inequalities. Okay? You can always ask, but most of the time I'll let you graph these with Desmos unless it's very simple. And then you could do simple ones by hand. You could definitely do this one by hand too, but it's going to be a little bit more complicated, so I'll let you use Desmos on this one. You can always ask if you're uncertain about what my expectations are, but simple should be by hand. More complicated can be on Desmos. So we want to maximize this. Let's graph our feasible region. So again, like when we graph it on the computer, C and T might confuse it. C plus 2T less than or equal to 40. Yeah, I wonder if you can tell it. If this is C and this is T, is it smart enough? No, it's not smart enough. Nice try. All right, well, you can graph it like this. The next one is 2x plus y is less than or equal to 42. And the next one is x plus y less than or equal to 25. All right, let's change to different colors. All right, so we have to be left of purple, under white, under blue, and in the first quadrant. So I'm trying not to block it myself. But where's the intersection of all of these three areas? Here, 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 which it might not let me plot without switching things up. 0, 20, 10, 15. This one was 17,8. And then also 21,0 behind my head. And let's not forget 0, 0 as well. These are the 4 corner points of this region. We have to check all 4, see what has the biggest profit. All right, so we'll make a little table. Say, let's look at our ordered pair C, T, and what our profit is. Let's find them all. Pick the winner. We want the biggest profit. So 0, 0, 0, 20, 10, 15, 17, 8, 21, 0. And remember, I said you could do this one by hand. You would just solve the system of inequalities and find out. You could like plot them and then say, I'm not sure where this intersects. Oh, where does this line intersect with this blue one? You could find those. You say, oh, I'm not sure exactly where this one is. Let's find where blue intersects with purple, and so on. So the profit, well, it's going to be 0 for this one. 0, 20 chairs, 0 chairs of 20 profit, and 20 tables of 30 profit. This one's going to be 600. This one's going to have, this third one's going to have 200 of profit and 4,500 of profit. 650. The last one's going to have 340 from chairs and 240. 340 plus 240 is 580. And this one over here will have 420 profit from the chairs. So the winner, 10 chairs, 15 table. We say the max profit possible is $650 from making 10 chairs and 15 tables. That's our answer. And again, to just kind of go back and do a little recall about what graphically this looks like. If we graph this profit, right, profit is 20C plus 30T. And we just graph different profit levels, right? These are all the things with a profit of 100, profit 200, profit 300. We want the maximum profit, 400, 500. Oops. 500, 600. You can see, right? As this orange line gets bigger and bigger, where is this orange line going to be the biggest? When it hits this one. And you can see that a profit of 650 should be right there at that corner point. We can't move this line any higher and still be in the feasible region. So that's why this is our maximum profit. All right, that's basically everything. If you want to see me do some homework problems, I do that in the next video. Otherwise, good luck.